Hello, my name is Landon, and this video is on molality. So, first of all, what is molality? So, molality is a measure of concentration. So, if we refer back to some previous chemistry knowledge, we should know that molarity and molality, well, they do sound the same, and molarity is a measure of concentration. The only difference is that molarity refers to the moles per liter, as where the molality refers to moles per the kilogram of solvent, kilogram of solvent. So this right here is going to be the main difference. Instead of being based on volume, since liter is a volumetric measure, we are going to base it off of a mass number. So in this case, the kilogram. So now that we understand the basis of molality, let's go ahead and jump right into practice problems. Learn by doing. Okay, so a solution is made using 79.1 grams of toluene and 80 grams of benzene. What is the molality of the toluene in solution? So let's look at the keywords here. What are we trying to find the molality of? We are trying to find the molality of the toluene. So if toluene is the solute, what is going to be the solvent? Well, the only thing left is benzene. So benzene is going to be the solvent. So now that we know the difference, let's remember it's moles per kilogram of solvent. So remember solvent is going to be in kilograms, and moles of solute is going to be in moles. Now that we know this right here, and now that we know what is which, what is a solute and what is a solvent, we can now start to calculate it out. So first of all, we must convert toluene into moles because we're trying to make the mole on the top and the kilogram on the bottom. So let's convert this to moles. So that will be 7.91 grams. So we can put that over 1, or sorry, not 7.9, 79.1 grams of toluene times the molar mass. It's handy. It gives us the molar mass right there. And that's going to equal, so let's remember we're trying to get to moles, so moles will go on the top. We are going to divide that, so divide 79.1 by 92.13, just like that, to get our moles. So when I plug that into the calculator, I get 79.1 divided by 92.13. That ends up being 0.86 moles. So 0.86 moles, that is going to be the amount of moles of toluene we have. So now that we found the toluene concentration, we need to find the amount of benzene we have. So I'll look at that. Benzene is already in grams, but remember it is in kilograms. So in order to put it into kilograms, we need to divide that by 1,000. I'll set up the ratios over here. So we have 80.0 grams of benzene, and we want to convert that into kilograms. So per 1 kilogram, there are 1,000 grams. So now if I plug that into my calculator, I don't even have to, that's going to equal 0.080 kilograms of solvent, or benzene. I'll just put benzene right here. So now, one last thing, we need to figure out what is the molality. We have both of these values right here. Now we need to figure out how do they relate to each other. So all we have to do is put 0.86 mole on top, and on the bottom we put 0.080 kilograms. And when I plug this into my calculator, 0.8 divided that by 0.0, I am going to get a molality of 10.75 molal. In other words, I will have 10.75 moles per kilogram of benzene. So that problem was easy enough. Let's move on to a harder problem. So you have a solution which is 38.4% by mass isopropanol in water. The density of the solution is 0.905 grams per milliliter. So what is the molality of the isopropanol in the solution? So first of all, let's identify that key word. Isopropanol is what we're trying to calculate, the molality of isopropanol. So you can see, let me just make that even bigger. This is what we're calculating. So now that we know what we're calculating, let's go ahead and figure this out. So first of all, we're going to want to figure out what is the mass of isopropanol. And so from that, we can derive how many moles we have. So we can assume, because the density is 0.905 grams per milliliter, we can just assume that we have about 90.5 grams of solution. From this, all we have to do is times it by the percentage of which we have IPA, because it says by mass, so the mass of the solution, 38.4% of it is isopropanol. So when we do this math right here, we get about 34.75 grams. From here, since we already know that we're going to need moles in the end, because IPA is going to go on top, IPA is going to go on top, we can just convert this into moles. In order to do that, we're going to do 34.75 grams over 1 times, for every 1 mole, there are 60.11 grams. So when you divide that out, you're going to get 0.58 moles of IPA. Okay, so now that we have the moles of IPA figured out, let's go ahead and figure out the weight, or the mass of water, since this has mass, or kilograms of H2O on the bottom, or kilograms of solvent. So now from here, we are going to, so since we know that 34.75 grams of it is IPA, we can therefore assume that 90 minus this number, so 34.75, shall yield our density, or not our density, our mass of water. So when we do that, we are going to get 55.75 grams of water. So since this already has to be in mass, all we have to do is convert this into kilograms, since this is in grams, as we can see right there. So in order to do that, we just divide by 1,000. I'm going to do that in my head. That's going to be 0.0575 kilograms. So all we need to do now is plug this into this equation right here, and that will be our answer. So 0.58, actually it's kind of already set up right here, but we'll just go ahead and write it right here. So moles IPA, and we also have 0.05575 kilograms of H2O. And when I calculate that out, I am going to get a molality of roughly 10.4. Remember, molal is represented in a lowercase m. So this right here is the molality of IPA in solution. That is it for this video. Thanks for watching.